Good morning. Everybody can hear me? Yeah? Okay, great. So I really like stories. I think stories teach us. I think stories entertain us. I think stories are a fundamental way that humans communicate. So this presentation will be in the form of a story. And it begins, as a lot of stories do, once upon a time. So once upon a time, there was a programmer. And she was quite a happy programmer. She liked what she did. She had a company that she liked to work for. She liked all her coworkers. And she looked forward to going to work every day. But there was one thing that she was missing, and that was time. There was so much cool stuff to look into, papers, talks that she'd heard, new libraries that she heard about on Twitter, and stuff that she wanted to hack. And by the time that she got home from work, cooked dinner, cleaned up, she just didn't have enough time to do it all before going to bed and getting up the next day. So she was in this frame of mind when she saw an ad for a cruise to the Bahamas. And she thought, I haven't taken a vacation in a while. This is a perfect time. I'm going to take a vacation for me, and it's going to be a hack vacation, and it's going to be great. I'm going to have time to do all the things I wanted to do. So she prepared. She invested in a waterproof suitcase for her laptop and her AR drone that she wanted to hack on, just in case, because she was going on a boat. You know, you don't want to get any spray on it, don't want to wet. And she packed her things and set off for the vacation. Day one was beautiful. Blue skies, warm weather, adult beverages, perfect. Day two, however, things started changing. Sky started getting dark, this big, weird cloud started rolling in, and the water started getting choppy, and the crew started running around, muttering about how they had just entered the Bermuda Triangle. And things just got worse from there. The boat started rocking. As she was running below deck to her cabin, she even thought she saw something that looked like a sea monster, but certainly that couldn't have been the case. So she ran down to her cabin, grabbed her suitcase with her computer equipment in it, was reaching up to secure it, and the boat tipped upside down, and everything went black. When she came to, she was clutching onto her suitcase, and there was just sand. She was okay. She brushed herself off, took stock of her situation. No boats or anything anywhere in sight. She appeared to be in an island that had nothing on it, no one there. But she didn't panic, because she realized that the first 24 hours in this situation was critical, and she'd watched a lot of Discovery Channel. And she came prepared. So she very calmly opened up her suitcase and took out her portable solar power generator and hooked it up to her laptop, and she was ready to code. So one of the things that she'd always wanted to look into, because she'd never been formally trained in computer science, was actually how to make a language. This parser thing seemed to be very interesting to her. So before she left, she downloaded this Clojure library called Instaparse. And what she really liked about it was one of the features, it said, Instaparse aims to be the simplest way to build parsers in Clojure. And it seemed like you could do it with regex expressions. So she wanted to start small. She'd never done this before. So she just wanted to say, just put in a 1, like an integer, and get back an integer. It'd be a small step, but it would be an important step. So she sat down, and at first requiring the library Instaparse. And then she started defining her grammar in her parser. And it was really nice in Instaparse because it looked exactly like a regex expression. She could just define a number as a regex expression for a digit. And when you executed this function, parser string 1, you got back a parser tree node with a number and the string 1. Very cool. But Instaparse had an even better feature than this, because you could apply transformations on it in a bottoms-up fashion, so you could use it for evaluation as well. So she could define a transformation on this number node as just read string, and parsing it through the input, you put it through the parser, and then transform and evaluate the nodes. and out comes a 1. Very small step, but very exciting for her. So she wanted to push it a little bit further. What if now you could just put in numbers, space-delivered numbers, and have it automatically turn it into a vector? Wouldn't that be cool? And she could do this by building up the parser a little bit more. So now, in addition to having numbers, she also had this thing called spaces. And when you put the angle brackets around in Instaparse, that means you want to suppress that parser node. So we didn't want that in the parser tree, but to know about it in the grammar. And you had vectors, which were spaces and numbers. And then we have expressions, top-level expressions, that it could either be a number or a vector. So now when she ran it through the parser, 1, 2, 3, 4, she got an expression, which had a vector in it, which had numbers, which had values, which were strings. Cool. So let's build up our transformations a little bit more. So in addition to the number, read string, we want to transform vectors by the composition of a vector in a list. And at the very top level, we kind of have it in the form we want to, so we'll just give it the identity function for an expression. The parse function didn't change. And now when she put in parse 1, 2, 3, 4, it automatically turned it into a vector. Very cool. She wanted to push it a little bit farther. So what if we had an operation and said plus 1, 2, 3, 4 and had automatically sum up the vector? That would also be cool. Again, just to build up the grammar a little bit more. So now, in addition to everything else we had before, we have operators, which are just string plus, string minus, and an operation, which is an operator and a space and a vector. And we have to, again, add it to our top-level expression, which is either now a number, a vector, or an operation. So when we go ahead and try this, we get an expression which contains an operation, which contains an operator, and our vector. So we have to build up our transformation again. So this is just like a little helper function. If we get an operation in here, whether it's a plus or minus, that just gives you back the actual closure operation, which is plus or minus. And we add that to our transformations. So, and if it's an operator, we choose our operator, and then the operation, we actually apply that plus to their values. The parse doesn't change, of course. And then when you execute it, it indeed sums them up. So she was really happy about this. But she felt like it was kind of missing something, because if it was going to be her language, she wanted to REPL with it, so it would come up and say it's my cool language, and she could type things in it. It would be really nice. And since it was written in Clojure, she could do this pretty easily. So she required her parser, and then she just defined a really short expression to be her REPL. So it would print out, the prompt for her cool language, and then it would read in the input and parse it, and then just print it out and just recur. Pretty simple. And of course, you'd have nice little hello greetings of whatever she wanted to say, cute, coming up. So she brought up her very own REPL with her own language for the first time, and it was great. She could put in 1, she could put in some numbers, she could add them up, and it was really cool. So she had a lot of fun with this, and the days passed on her island. And she had her AR drone, and she flew her AR drone all around the island. She was indeed the only person on it. And she found some fruit trees and some stuff to eat and some wood, and she built a really cool tree house. And she started building up more features of her language. So that was a lot of fun too to her. But even though she kind of had this and had all this time to hack, she kind of felt really lonely, because there was no one to talk to. And she really didn't realize how much she missed talking to people until she was just in this alone situation. And she was kind of sad and feeling this way and walking along the beach when she noticed a suitcase had washed up. It was an old, battered suitcase and waterlogged, and when she opened it up, it had mushy things in it that I guess used to be papers, completely unreadable. But there was one thing that had survived. It had been packed in a Ziploc bag, and it contained a book and a paper. And the book was Speech Acts, an essay on the philosophy of language by John Searle, and the paper was Elephant 2000 by John McCarthy. And she took this as a divine act of providence and sat down on the beach right there and started reading the book first. And it was all about, what does it mean to speak? So when somebody says, pass the salt, what does that mean? I mean, certainly sounds come out of your mouth, these utterances, but there's a higher meaning to that. Whether you're speaking in English or French or Spanish, you actually want somebody to give you that salt. So this is what this is all about. It's this higher order of meaning to language. And this higher order of meaning to language is called in philosophy speech acts. In particular, they're called elocutionary acts. These were coined by Austin in How to Do Things with Words in 1962, and later expanded on by Searle in 1969. And it's easy to explain it kind of in examples. So an example of an elocutionary act is assertions, it's hot, or commands and requests, please pass the seaweed, or queries, do you see a coconut? So there's another kind of speech act as well, and these are a little bit different. These are called perlocutionary speech acts. And these were coined by Searle in the Speech Acts book in 1969. And these are not so much concerned with direct actions, but the effects that these acts have on the actions, thoughts, and beliefs of the hearers. So examples of these would be to persuade, to convince, to alarm, to scare. So she then picked up the paper by John McCarthy, The Elephant 2000, and it talked about these speech acts as well. And in it, it had his ideas about programming language, in which the communication and inputs and outputs were based on these speech acts. So why would you want to do this in a computer language? Well, he thought, what can computer language use of speech acts learn from the extensive use of philosophers? And what light can be shed on the philosophical problems when we consider how we want to use speech acts with computers? And finally, that speech acts are necessary in a common sense informatics situation in which people interact to achieve goals. And this is a cool thing, that it's independent of being human. If we took a spaceship and actually went off to a planet where there were aliens, they would have some sort of language where they communicated, which would include speech acts. So Martians or robots would need the same thing. So she thought to herself, why shouldn't my REPL have speech acts? So she started trying to program them in. So she started with the easy ones first, asserting, right? Lots of programming languages have assertions, an elocutionary speech act. She could assert that Sunny was true. And then she added answering queries, also an elocutionary speech act. You could say, query the value of Sunny, and it would be true. And she added in requests, which is an elocutionary speech act as well, like pass the salt. But this is kind of interesting, because when you accept a request, it actually creates an internal commitment that is performed at some future time. So she thought, maybe I'll add a new data type, and I'll call it a commitment. And I'll denote it by an asterisk, so it could be like pass the salt. And then my REPL can keep an internal list of commitments. And then I could have like a cron-like process that could continually check to see if there's any commitments that needed to be performed. So for an example of this at the bottom, if you had a request to pass the salt that would perform a function of just returning back a keyword salt, it would actually create this commitment. Well, she was also, this was cool with the speech acts, but she thought, wouldn't it be cool if my REPL also had beliefs? And she'd remember this is something that John McCarthy had also talked about in one of his papers, ascribing mental qualities to machines. It might seem kind of strange, but there are some good reasons that you might want to do this. And I'm just going to kind of read some of John McCarthy's thoughts on this. Although we may know the program, its state at a given moment is usually not directly observable, and the facts we can attain about its current state may be more readily expressed by ascribing certain beliefs and goals than in any other way. And the belief and goal structure is likely to be close to the structure that the designer had in mind. It may be easier to debug. So she added another data type, a belief, denoted by a pound sign. And this belief is described by a predicate function, and when this predicate function evals to true, the belief is held. So now she could do a paralocutionary speech act. She could convince her REPL. So she could convince her REPL that it was a nice day if this function, sunny, evaluated to true. And she gave it a string that would describe it. It is a nice day. So now she was getting somewhere. So now she could do requests with beliefs. So she could first assert to her REPL that it wasn't sunny, then convince it of the belief that it was a nice day when it was sunny, and then give it a request to open the window when it believed that it was a nice day. So if she asked it at this state, is your request done? Did you open the window? It would say no. It's not a nice day. And the minute she asserted that it was sunny, it would go ahead and open the window. So this is cool. She had her REPL. Her REPL had speech acts. It had beliefs. It'd be really nice if she could just hear somebody talking to her too. So she decided to give her REPL a name, Babar, and to actually have it talk to her with the say command. So we're going to try to do a demo of this right now. Oops, sorry, went a little bit too far. Okay, so first she gave it a speech config, so allow her to speak to her. And we're just going to go through the kind of example it did before. So asserting that sunny was false. And now convincing the REPL that it's a nice day when this function sunny evaluates to true. And now giving it a request to open the window when it believes it's a nice day. It'll print out the open the window. That was my request again. Sorry, getting nervous. That's 5 snippets. Okay, so you ask the query, is the open window done? False. So now we assert that sunny is true.
It is a nice day.
So now we can ask it, is the request done? True. Sorry. So now this is cool. She had somebody to talk to, speech acts, she could ask her questions, I could talk to her, but why couldn't it ask her questions itself? Like if she put in something silly, like some unbound var, why couldn't her REPL ask her, hey, what's X? So she programmed it in and as an ask config, and we're going to do a demo of that too. So, right. So again, tell it to speak, and ask config. Okay, so here we're giving it a request to do a task with a function that has an unbound var.
Query X.
So it asks her, you know, what is this? And then you could ask, is the request done? Well, no, because it doesn't actually know what X is. Oops. So now if she goes ahead and asserts X and asks it, then it'll go ahead and perform the request for her. So she was having so much fun with this, talking to her REPL, having conversations, that she almost didn't realize when she was having this that she saw a ship on the horizon. So it was, you know, it was just sailing around. She tried to signal it the best that she could. She was hoping that it wasn't too late. She took her drone, she flew it up. She tried to signal the boat with the drone, but it was too late. The boat had sailed on. So she sat down with her REPL and said, what can we do? How can we make sure that we won't miss the boat again? And it came to her that she needed to get her drone in on this speech action. So luckily, the AR drone has a camera. So while the boat had been out there, it had been taking some video of it, and she had OpenCV already on her computer. So she used the video to train the drone to recognize the boat. So the next time that the boat would come by, it would recognize it. And her plan was to have the drone fly up with some earrings that she had in her suitcase. She'd attach it to be nice and sparkly. And it would fly up and kind of do like a dance shake thing, and then the boat would see this, and then she would be rescued. So this was her plan. So she wrote a program in her language. First, she, of course, wanted it to speak to her, and she imported some libraries that she already had in Clojure to control the drone, and just did some drone initialize functions to talk to it. And she just made some helper functions too. So this is going to go ahead and get some navigation data from the drone. The AR drone, Parrot drone, is a wonderful thing. I'll just speak a couple minutes on it real quick. It has a camera in the front and a camera in the back, and it's got sonar, and you can get back all sorts of navigation data, so you can tell how far it is off the ground and whether it's in a flying state or a landed state. So she wanted to hook into all this information in her program. So the first thing she was going to do is to assert that it didn't see the boat. And then she's going to convince it that it is going to see the boat when see the boat var is true. And then she's going to convince it that it's flying when its navigation data, and this is the navigation data coming back from the drone. Oh, so the drone itself has a Wi-Fi in it, so you connect the computer to the Wi-Fi and talk to it this way. So when the navigation data is in a control state of flying or hovering, that it would have the belief that it's flying. And it would have a belief that it was high enough when that navigation data from the sonar got to 1.3 meters. And so now that she had the assertions and the beliefs, now she could make these requests with the beliefs. So she wanted to take off when it spotted the boat. So that drone takeoff is the command to control the drone. She wanted to go up at a rate of 0.3 until it reached a cruising altitude, and then it would stop when it was believed that it was high enough. And then she wanted it when it was high enough, and it had done, it had hovered and done this like little dance thing. She wanted it to land. So that's the plan. But it's hardware demos, so we're gonna see what happens. So at this point, I'd like to give just a short safety. Okay, so the AR drones are they're just a really safe consumer product, and I have caught it the wrong way before and put my fingers in there and it just hurts, and look, I have all my fingers. So it's an incredibly safe thing, but there is like a little technique. So it should just go up and do a dance and then come down right here. But if something goes wrong, I want you all to be aware of how to catch it if the need may be, especially you guys in the front row, right? You didn't know this coming in. So this is how not to catch a drone. Okay, doing this. No, that's not a good way to catch the drone. So this is how to catch the drone. So catch it on the bottom and then flip it. Yeah, and then the engine cuts out, okay? So we're all We're all good on this? Okay. Okay. So at this point, I'd like to introduce my drone catchers that are going to be on the stage. These are Ken from NEO as well and John from NEO. So they're just going to cover this side, and you guys are responsible for this side. Okay. So let's go on with it. So first I'm going to plug it in. And in case you're wondering about all these strange markings on the floor here, this is just so the drone is, when it takes off, when it hovers, it needs something to look at it on its downward-facing camera. And if it's a featureless floor, it tends to drift more, which we're going to try to minimize at this point. Okay. Make sure my earrings, did you all see my sparkly earrings? It's wonderful. So I have sparkly earrings on here, but I got to make sure it's straight. Okay. All right. Okay, so the first thing we need to do is connect to its Wi-Fi. And there it is. Wait for green. Come on, green. Yes. And we're going to switch to a fresh shell. And we're reading in that program that we just kind of went through. So that's Spot Boat. Okay, and here's our commitments and our beliefs and speech acts and those sort of things. All right, you guys ready? All right. I see the boat.
I see a boat. I am flying. I am signaling the boat. I am signaling the boat.
Yay, good job. I'm so happy it actually worked. That's awesome. Okay. That's all fun from here now. We're done. Whoop. Caught up here. Oops. So, well, oh, I had a backup video in case this didn't work, but we didn't need it. Yay! So,
I see.
let's get out of there. So, she was rescued. Yay! All her stuff worked. And the first thing she said to the real person that she saw that came with the boat was thank you. And that's a speech act too, but she hasn't worked that in her RAPL quite yet. So I guess in closing, a recap here, Instaparse is a really beautiful parser. And I encourage you all to check it out and just create your own languages, because it's really just a wonderful way to do it. And if you haven't done that or played with the language or created a language before, please try it. It's a lot of fun. So computer science can learn from philosophy, and philosophy can learn from computer science. And I think this is a really interesting area, especially in AI. And these speech acts are meaning behind our communication. So whether this is with humans or with machines, and I think it's especially important when we're considering how interconnected we all are with machines and other humans. Oh, okay, so this was just like a tiny toy programming language that I was playing with. But in my explorations, I came across a real full-blown programming language that actually uses speech acts, and this was just released in September, and it is open source. It's the Star programming language on the Java platform, and it was created or co-created by Frank McCabe, who is also a co-creator of the Go programming language. So it is indeed a full-scale programming language, and it incorporates a simplified model of speech act theory, as a basics for its programming actors. So it's kind of cool. So STAR has actors and speech actions. So it's kind of a cool thing that I found out. And also, you should definitely read John McCarthy's papers. They're just a gold mine. He has wonderful thoughts on philosophy, computer languages, AI. They're great. The thing that makes me sad is this link won't work for you anymore because just last week, the site was disappeared from the internet. So you can get to it on the Wayback Machine, but if anybody has any contacts at Stanford that I could talk to somebody and convince them to get it back up or move it somewhere else, I would appreciate it. Playing with drones and Clojure is just great fun. I've had a wonderful time doing it. The few libraries that I've written are out on GitHub, and you can feel free to check them out. There's BabR, which has all the stuff that we've talked about in the demo, and also CLJ Drone, which you can control your drones as well. I haven't worked core async into controlling multiple drones, but it's definitely on my list. That's it. I ended a little bit early, so if anybody has any questions. Just remember, if you're asking me questions, I don't really know a lot about philosophy or language parsers or anything like that. I do know fairly a lot about the AR drone, so you can feel free to ask about those questions there, but anything? No, I totally shut down the questions. Oh, okay.
So the question about the commitments, is the idea that they only get executed once? Or can you have something like recurring commitment that happens again?
Very good. I do actually have recurring commitments. You could have them be recurring, or you could also have them being executed until they had a belief. So instead of, so I have a little bit more in the README and the BabR. So, anything else? Oh, sorry, yeah.
Is there any relationship between speech acts and implementing this on a blackboard, or has anybody tried to implement blackboards in Clojure?
I've heard a little bit about the Blackboard method, but I don't understand it all. So if you want to explain what a Blackboard is to everybody, that would be.
Okay, well, I'll try to explain Blackboard. The idea of a Blackboard is that there are facts that exist in sort of, let's call it a fact database, and then you can have things happen and certain facts change or become true. So a belief would be an example of a fact.
Oh, okay.
So you can basically attach actions to facts in Blackboard, and things will happen. So when, for example, one thing that might happen is where there's an instance of a class that's created that can trigger events, or when a fact changes that can trigger events. And so I've done this in Common Lisp, and it's a little bit clunky, so I'm wondering if anyone's used Blackboard stuff in Clojure.
Has anybody used Blackboard stuff in Clojure? Sweet, sweet. Anything else? Oh, yeah?
How do you use OpenCV with Clojure?
Okay. So OpenCV has Java bindings now. So you just build the OpenCV library. You have to have the native libraries in there, and then just use a jar to communicate with it. And I think that somebody's written maybe or they've been playing with a Clojure wrapper for it as well. So. Okay. Yes?
Okay. How long until you get operating drones?
I'm sorry, how long until?
Operating drones where you have multiple drones flying, they're wearing each other?
I have had multiple drones flying. The farthest that I've done with multiple drones is have two fly with goals and beliefs. They took off, and this is an interesting thing that Oh, this one doesn't have tags on it, but there's little tags that you can put on the side of this, and the hull, they're predefined that the drone can recognize it, and see it and tell you what, distance it is from it. So I had the 2 drones fly up and kind of turn around until they believed that they saw each other, and then they waved to each other, and then landed. So, but yeah, you can get multiple drones flying in coordination to each other. You need to fiddle with the network settings a bit. Let me see what I'm doing time. Okay. Fiddle with the network settings a bit to get them in pure network mode, and then you can get them all talk together. So, and if anybody's interested in how to do that, I had to get a shell strip that's kind of custom that you put on the actual BusyBox Linux there. So it's documented on the CLJ Drone GitHub if you want to get your fleet swarm going. Anything else? No? Well, cool. Well, thank you guys very much. I enjoyed it.